So started.
Hello everyone, I'm Aslam Nesakul, and in today's generative AI crash course video, we'll be talking about image generation models. And today I have with me Jack Min, who is presenting. Hi, Jack.
Yes, hello. So I'm Jack Min. I've worked on diffusion models, and so today I'll be bringing you all through that.
All right. So, can you tell me what are we going to do exactly today?
Okay, so first we'll start off by like how you use diffusion models, and then I'll go a little bit into fine tuning, and then also show like a small fine tuning and how that works. And then I'll go into like how you can explore on your own, which communities you can go for, and what resources you can use to learn more about the text to image and diffusion models.
Interesting. So, sounds like we're going to learn a lot today about image generation. So let's start with.
Okay, so yeah. So first, if you want to be able to use diffusion models, the easiest way is to use a Colab. If you have a laptop that has GPU, then you can just run a notebook off of there as well. But for those of you who don't have access to GPU, then probably the easiest way for you to get started is to use a Colab. So yeah, basically you just start a notebook, and then the first thing you have to do is you have to change your runtime type. So that's under the runtime, change runtime type, then you choose GPU. I mean, you can run it
Mhm,
on CPU, but just it will be really slow. So since Colab is providing you free GPU, that's always a good idea for you to go for that. Okay,
mhm. So
then yeah.
the good thing about these models, you can do inference on, let's say, consumer grade GPUs, and also you can train on such GPUs, which is a bit in contrast to language, some of the language models where some of the Colab GPUs are not sufficient.
Yeah. These days language models are pretty big. I think if you're like doing the fine tuning, the LoRa stuff can fit, but yeah. If you're doing like full, then you
Yeah,
probably won't fit. Okay, so first thing you need
exactly.
to do is install diffusers. Okay, that should take a while. I think it's pretty
Mhm.
fast because I think most of the libraries are already like installed on Colab. Okay.
Yeah. So diffusers is a package from Hugging Face, and I guess it allows you to pull Hugging Face image generation models from the Hugging Face hub, and then use them to perform image generation, right?
Yep. Yeah. So yeah, that's basically what it does. So like transformers is Hugging Face's library for like the LLM stuff, and like transformers. Yeah, actually, even though it's called transformers, most of the time the LLM stuff stays there, and then diffusers includes like the diffusion models. And actually, diffusers has a dependency on transformers because you also do need like a text encoder inside diffusers. Yeah, but the stable
Interesting.
diffusion stuff would stay within diffusers. Okay, so first thing
Okay.
you do, easiest code is like from diffusers, import diffusion pipeline. Okay,
Mm-hmm.
then you just instantiate this with a from pre-trained, and then you
Mm-hmm.
specify a model that you want to use. So today I think we'll just use Stable Diffusion v15. You can use XL, but XL is going to like increase your inference time by like quite a bit. So
Mm-hmm.
since we're just doing a tutorial,
But,
it's easier if we just go for
yeah,
1.5.
but,
Yeah.
but can you give us some context about Stable Diffusion? What is V1.5 and what is Stable Diffusion XL? Quickly.
Oh, so Stable Diffusion is a diffusion model trained by Stability AI along with some collaborators. So yeah, I think they have something where they also distribute it differently. So 1.5 would be on Runway ML, whereas for if you're doing
Mm-hmm.
2.1 or XL, that would be on Stability AI's organization. Yeah,
Mm-hmm.
but basically the
Mm-hmm.
model does. You want me to explain the architecture? I guess.
No, we can go through it later, maybe.
Okay, sure. Yeah, but
Yeah.
basically it's a the diffusion model trained by Stability AI et al. Okay.
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 And this from pre-trained line basically allows you to pull the model weights from Runway ML's Hugging Face repo locally, and then you can use it for inference data.
Yep. Basically that's it. Oh, this is 154. So yeah, you can see Comfis also has one. So they're scattered all over the place. So yeah, you can see 151 is on Runway ML. Yeah.
Yeah. So basically, we will be pulling this exact model. Maybe you can show us the weights in the files.
The weights and files, okay, sure. So like files and
Yeah.
versions. So
Yes.
yeah, there's like 7 components of it.
Nice. Interesting. Okay, let's just use them for now. Maybe we can look at this later.
Yeah, sure. It'll take some time to download, so I have some time to talk about it. Okay.
Oh.
But first, here I'm specifying some parameters so that I can load it in a lower precision.
Mm-hmm.
Okay.
So
So
we are using FP16 here.
yeah, we're using half precision. Yeah. So that will make your inference like around, I think, 4x faster. So it's always a good idea to go for it. And it doesn't really change your output that much. I can show later, like I can get the full precision one as well, and also run
Mm-hmm.
inference on the half precision one. You basically won't really notice a difference. Yeah, the image will basically do the same. So yeah.
Okay. So to sum it up, we pull the model weights from Hugging Face. We try to convert them to FP16 so that we can use less GPU VRAM, and then like we need to send the model weights to the CUDA device using this two CUDA
Yep.
line.
You can also actually get away with not specifying this variant. Like the casting to FP16 actually only depends on this torch D type. But what this
Mm-hmm.
variant does is it makes your model weight pool cheaper. So you can see like over here, it's pulling the
Oh,
model.fp16.safe
oh,
tensors. Like if you
oh.
didn't
So okay,
specify this variant, it will pull the full precision one, which would be like
mhm.
double the network, right? So
Okay. So can we see this file in the Hugging Face
yeah, you can.
repo?
So if you were here, like you could go to the unit. So
Mm-hmm.
it's a bit short, they shortened it. But yeah, you can see that
All right.
there's diffusion model without any special things. This one will be the full
Mm-hmm.
precision one. So you can see this one is like
Okay.
3.4 gig. And then you can see there's
Okay.
this .fp16 .safe tensors one, and this one is half.
All right, interesting. I always thought Hugging Face will pull the full precision weights and then convert them locally to a half precision weight.
Yeah,
But
I
yeah, I
think
think it's
that's
a
how
nice optimization.
Transformers does it, because Transformers hasn't gotten to this variant feature. But I predict like in the
Mm-hmm.
next 2 years that like maybe I would be willing to bet that they will try to implement this feature as well. Yeah, but I think Transformers
Understood.
right now does not have this feature where you can specify a variant to pull. Yeah, whereas
Okay.
diffusers they do. Yeah, I guess because people are complaining that they don't have enough disk to store some of the diffusion stuff.
Yeah, I told you, Jack, we need to make a model hub. I told you, a new model hub.
Yeah. You basically want a
Okay, let's.
bundler like front end, yeah. But anyways, okay, back to this. Okay, so now that we've loaded it, when you get like the repo of the pipeline, you'll basically see all the components inside the pipeline. So yeah, there's this feature extractor. This basically to like do some image stuff. There's no image
Mm-hmm.
encoder. I think this is. I'm not sure what uses this actually. Yeah, then there's a safety checker, which just
Mm-hmm.
checks to make sure it's like safe for work. You can disable it by setting it to none if you want to see all the images, but then you're in a bit yeah, you might be exposed to images you didn't want to see. There's also the scheduler for noise, there's a text encoder, tokenizer. These are standard transformer stuff, and then there's a UNet, and then
Mm-hmm.
there's a VAE. Okay?
Okay,
And
interesting.
yeah, the way you use it is you just call the pipeline and you pass your prompt. So yeah, you can pass anything. But I think like the hello world of the diffusion world is astronaut riding a horse on the moon. Yeah, I think they just use this as a hello world because it's like a image that would be like nonsensical, so it's probably not in the training data. So they're trying to show this like, oh yes, it generalizes because it can generate astronaut riding a horse on the moon. Yeah.
Okay.
Okay.
I actually wanted to see your hello world, not the um, generic one. But yeah.
Oh, I'm actually not sure what it would generate on Hello World. Let's try that. Okay. Would it have worked? I think
Oh,
it would.
I meant like your hello world. What is the image that you always generate all
Oh,
the
I
time?
always do like cat wearing a hat.
Yeah.
it's like I can type that faster than like astronaut riding horse on the moon. But you can see, yeah, you can get an astronaut riding horse on the moon. Yeah.
Nice, nice.
And cat wearing a hat. Let's wait for this cat. Or the hat's kind
Ooh,
of like blended into the ears. So yeah, doesn't
beautiful,
always
beautiful
work
cat.
out, but yeah, sometimes you get decent images out of it. Yeah. So right now, if you like keep specifying this, you always generate a different image. So I can run this again. So this takes about 7 seconds. Okay. Then it should give me a different image. Okay.
Where does the randomness come from?
So the randomness, if you don't specify anything into the pipe, then it always generates a new random. So you always get a different image. But if you want it to always generate the same thing, then you have to specify a generator to the generation. So the way you do that is you just specify generator equals the torch dot generator. You have to specify the device that the generator is on. And then you do this manual seed thing. So let's say I go for 42. Okay. And so now, if I copy this and do the same thing here, I should get both of them as the same image. Okay, so we get this image. Yeah, it's a bit muddy, his legs. Yeah. Over here, yeah.
Oh yeah, maybe you can.
Exact same thing.
Nice, nice. Okay, so you guys know when you want to generate the same image over, like you specify this parameter. But can you tell us quickly, what is this 50 iterations or 50 steps?
Okay.
When you generate
So
an image?
yeah, basically, yeah, I think I have at this point I have to explain the architecture. So we'll go over here. Okay.
Okay.
So okay, let me just present this. Okay, so this is how the Stable Diffusion architecture works. So there were like 7 components, right? So this is roughly how they fit together. So what you would do is you will pass like a text prompt. So for example, a blonde woman with wings playing piano. And then this text prompt will go into the tokenizer, which basically spits in tokens that you can pass into a text encoder. It's basically like a language model, but then instead of predicting like next token, you don't have a head. So you just have the transformer output at the end. And so this will be the text embedding. Yeah, and in the case of the clip encoder, their max sequence length was 77, and their embedding size was 764. So basically, you get a text embedding at the end that's 77 by 764. And then what you do...
Sorry, what is 77? So what is 77?
Oh, the 77 is the max sequence length for the clip encoder.
Oh, I see, okay.
So if your prompt
but if you...
Yeah, go on.
Yeah, if the prompt is less than 77, do you still get 77? No?
Yes, you still get 77. So basically pad up to 77. Yeah.
Okay.
And if you're more than that, then yeah, you get truncated. So if you specify a prompt that's too long, it won't know what you said at the end. Yeah.
Okay. So I think we discussed earlier the context length or sequence length in language models, which can be like 512 or 1000 or maybe even 8000 and more for language models. But you know that for stable diffusion models, the sequence length for the text prompt right now is 77, right? Maybe there are other image models that support higher sequence length.
Yeah. Okay. Yeah, but like if you're doing like images, like captions usually aren't super long, so I think 77 is actually reasonable for you to fit most things. So it's not a bad token length to start with. Okay, and then what you do is you feed this into a UNet model. So UNet is basically this model that like predicts from image to image. And what you're trying to do is you will start off with this image that's just like all white noise. And then at every step, you will try to predict like the noise in the image. And then you will minus that from the noise to get back the original image. I'm not sure if that made sense.
Okay. So we start from noise, right?
Yeah. You start from noise, and basically what you're asking the model is like, given this text prompt, Like
Mm-hmm.
how do I change the pixel values to get an image that matches this text prompt? And so it just gives you
Okay,
those
so
pixel values. Yeah.
so the unit, it predicts let's say values that you use to subtract from the original image, right?
Yes.
Okay, so we start from a noise,
Mm-hmm.
and the unit predicts values that we need to subtract from the noise, which makes the new image look more like the intended image, right?
Yep. Exactly. Yeah.
Okay.
Okay.
And what is this scheduler?
Okay, so this scheduler thing is this idea in diffusion that you can't do it all at once. Like you want to make this an iterative process, and then so that the model in a way can correct for its errors. Yeah. So I can show you later, like if you go for like if you try to diffuse like too quickly, so you use like very small amount of steps and every step you subtract a lot of the noise, then you won't get a very nice
Mhm.
image. But if you subtract like incrementally, so you have it predict the noise, but you don't subtract all of it at once. So you subtract a little bit, and then you ask it to predict again, and then it subtracts a little bit, and then like at the end it has finished subtracting. Then you decode it back out into the image. Yeah.
Mhm. Okay, then if we look into the GIF, the image that is being generated over time. So basically, we start from a completely noisy image, and
Mm-hmm.
then over steps we try to modify that initial image so that it looks like the final text prompt, right?
Yep, yep, that's basically it. So basically, you're
Mhm.
showing it like noisy image, then you're saying like, okay. So it's like very different from how a human would generate art, because like humans, you generate like pieces at once. But for the
Mhm.
machines, the way we do it is we give it a bunch of noise, then we ask it like, okay, change these individual pixel values to make like a bunch of fruit in front of a banana leaf, and then it just like modifies each pixel value iteratively. So
Okay,
yeah. I
interesting
don't think a
approach.
human would actually be able to do this, but somehow the machines are
Mhm.
very good at this. So that's
Okay,
that. Yeah. Okay.
and does the noise, initial noise, correspond to the generator parameter that you specified?
Yes, correct. So yeah, the unit is deterministic, but then there is a random aspect to the image that it generates because you will start with a different noise at the start. And so in order to
Mhm.
generate that starting noise, the generator is used. And so that's why if you specify same generator, you start with the same white noise and you end up with the same image.
All right, right. And then I guess there is an important aspect about stable diffusion, like the innovation that stable diffusion came up with was like diffusing in latent space, right? Can you
Yes,
explain what
yeah.
is
So
this
it's like
latent
a
space?
latent diffusion model. So like originally like this idea of like minusing pixels in the image, like you'd want like the I think Imagen started with this, and what they did is they would just minus it in the image space. But then if you minus in the image space, you have an issue, which is that you are very high in parameters. Like if you wanted to generate like an image that is 512 by 512, so the number of pixels that would be in there would be like 256,000. Yeah. So your last layer would be 256,000 the pixels that you'd have to generate, and then like your before layers would also, like even if you did an upscale, you would also be in trouble in terms of the number of parameters you would need. Yeah. And
Mm-hmm.
so what you want to do instead is you want to, since you can use a VAE, basically an autoencoder, and what the autoencoder does is it maps something that is in a higher dimension to a lower dimension. What you can do is map from the image dimension, which is originally 512 by 512, and for stable diffusion, they map it down like by 8, so to 64 by 64. And so now 64 by 64, you're basically around 4,000 pixels. Yeah. So that's a lot less parameters. And you basically want to diffuse in this space where each pixel movement is now more meaningful rather than if you had tried to diffuse in the image space. So first you save the
Mm-hmm.
parameters, and also you make it that each movement is now more meaningful in the semantic space. Yeah.
Interesting. So the latent space is basically a compressed representation of the features of the images,
Mm-hmm.
right? and then we diffuse on this latent space. We try to come up with a representation, a feature representation that matches the most our initial text prompt. And then when we finish generating this feature representation, we map it to pixel space, to an actual image that we can see as humans, right?
Yep. Yeah, that's basically it.
Okay, and this VAE decoder, is
Mm-hmm.
it trained jointly with the Stable Diffusion model or trained separately?
They're usually trained separately. So actually, like Stable Diffusion, the paper only talks about this unit and scheduler portion. This text encoder, so you can see there's like a clip here. Basically, they took it from clip. And then this VAE decoder, they had one that was trained on open some there was some open image the data set. I think some of the Lion sets, and also there was a specific human data set that they trained on, so that it generates humans better. Yeah. So basically, this is trained separately from the unit. So you would train the VAE as a VAE decoder and VAE encoder, and here you would use like some MSE loss to like reconstruction loss, and then for the UNet you would basically freeze all the other models and then only train the UNet to generate conditionally. Yeah, and here also you
Mhm.
actually do a reconstruction loss. Yeah.
Okay, so when we fine-tune the Stable Diffusion model, we only change the parameters of the unit schedule, right?
Yep, yep. And I think there are some people who also want to change the VAE decoder because the decoder will have a bias to the images it was trained on, right? So I think the people who are training on like anime images, they are interested in changing the decoder so that it better represents anime images that they're interested in. Yeah.
Oh, I see. Okay, nice advice.
But for the most part, you would usually only touch the UNet or maybe the text encoder. Yeah.
All right. Okay. Um, so what do we do next?
Okay, so I think I full screen this. So, okay. Oh no, where was I? Okay, I was here. Okay. Yeah. Wait, what did you ask me? Oh yeah, so now I need to show that. Okay, so here the default number of steps it always takes is 50, but you can also
Mhm.
specify a number of steps. So I can do like inference steps equals to 10. Okay. And then you'll see it will generate a lot faster. So this was like 7 seconds.
Mhm.
And this was generating in 1 second, but you can see it's like a little bit butchered. Like the
Oh yeah.
general composition is like kind of the same because they started with the same noise since I'm specifying the generator. But then because it tries to diffuse like too quickly, the details get lost, and yeah, you can see it's like, yeah. Though interestingly,
Okay.
it looks a bit more like the like a rough draft. Like you just pasted a horse and then you pasted a national. That's kind of what it would look like.
Oh yeah.
Yeah.
And then it tries to blend them together.
Yeah. So I guess the intermediate steps is just like blending them in. Yeah.
Okay. And do you think it's easy to visualize each step individually, or you think we can do that?
You can if you deconstruct the pipeline. Yeah, but yeah, you would have to dig into the internals of the
Okay,
configuration.
then no
Yeah.
need for let's skip it.
Yeah. But if you when you get into the training, I can like roughly go through the training code. You can probably see it in there
Mhm.
if you want. Yeah.
Okay. Okay.
Okay.
Yeah,
I
sure.
think the docs diffusers doc also has something about this, so you can probably read that. Cause I think when I started learning diffusers, there was an example that didn't use the pipeline. Like they would just
Mhm.
load the like 5 components like individually, and then like take you through like
Mhm.
a for loop to get back the original image. Yeah. Then that one you can get like the intermediate representations as it was generating. Yeah.
I see.
Okay.
Yeah.
So yeah, this is how you would use Stable Diffusion on like in like a notebook, so in like a code setting. But a lot of time if you're just an artist or you're just like experimenting with the model, this is kind of clunky. Like you want to have a UI where you can like modify the parameters and specify what you want. Yeah. So
Mhm.
the UI I think most people use right now is one by Auto 1111 or Auto 111. Yeah. I have no idea what
Mhm.
people say because everyone says something different. Sometimes people just say auto because the 111 1 and 1111 is like, yeah,
But who
200.
is this guy? Like,
He's just
who is this
this,
guy?
like, nobody knows.
Okay.
But he
Oh,
just
wait.
maintains
What?
what?
100K stars?
Yeah.
Come on, give him a star. Come on,
No,
Jack.
I'm not signed in. I think if I signed in, I think I gave him a star.
Ah, okay, makes sense. All right.
Okay. But anyways, yeah. So yeah, you're basically that it has this UI where you can like specify your prompt, and then you can specify negative prompt as well, and then yeah, it generates the
Mm-hmm.
images. Okay,
Okay.
so there's installation instructions somewhere. So yeah, I think most of you will probably be on Windows, so I guess you follow this one. For me, I happen to be on Linux, so I was using this one. Apparently, you can also install an Apple Silicon. Yeah, I think this is new. I haven't really tried it yet, but yeah. So what I've done is I've launched it on a Linux machine that's remote, and so I just
Mm-hmm.
expose a port on that. So I'll just
Okay.
do actually.
Is it your GPU server?
Yes.
Nice. From Malaysia, right?
Yeah, yeah, yeah.
Interesting.
Because I did actually try it on Apple Silicon, so I can like quickly go. Because I think some of you might have Apple Silicon. Yeah. So
Mm-hmm.
if you try to run Stable Diffusion on Apple Silicon, even if you're at FP16, so here I was also using MPS, which is Apple Silicon's accelerator. You see like
Mm-hmm.
generating like 50 inference steps, it still takes 1 minute. So it's like 7 seconds versus 1 minute. So it's like 6 times slower ish. No, 10 times. Yeah, slightly less than 10 times slower. Yeah. So if you don't have access to GPU, I guess it's still fine if you just want images. Like, yeah, but then you have to
It's
wait 1 minute versus
it's
waiting
just
seven
slower.
seconds. Yeah. Okay.
When does this software install or pull the model weights for you and has already the inference software, right?
Um, it starts off with the base Stable Diffusion. So I think if you just like a fresh install of Auto 1111, you'll have this V15 pruned EMA only safe tensors. So this is
Mm-hmm.
actually Stable Diffusion version 1.5, and then there's some pruning that they did, and EMA is this exponential moving average. Yeah, basically some
Okay.
modifications to the way that it inferences. Yeah, but
Mm-hmm.
basically it almost generates the same as the vanilla Stable Diffusion v1.5. So you can do like a cat wearing a hat. Okay.
Okay. So guys, this is the new hello world for image generation.
Yes.
Don't use the astronaut.
Then yeah, you get cat wearing hat. You can also increase the batch size here. Yeah. For the notebook, you can actually also specify batch size, but then it's not that nice to display because I think the notebook you can display like grids, but then you have to write custom code to display grids. So yeah, it's nicer
Mhm.
if you're on a
But
UI. Mhm.
batch size here basically means that you create four like noise images, right?
Mhm.
And then you send them in batch to the model, and then you generate new image, all of them in batch, right?
Yeah, correct. Yeah.
Okay.
And then if you want it to be reproducible, so if you put -1, then it always generates a different, it starts with a different seed and generates different images.
Mhm.
But if you press this recycle, then it will get the seed of this generation. So now when I run it again, I should get exactly the same 4 cats. Yeah.
Okay.
Okay. Yep. Okay. And
Okay.
then
What is this image to image tab?
so this image to image tab is like basically you can start with an image and then generate a new image, like you add some noise to that image and then regenerate it. So usually this is if you have an image that you kind of already like but just want to make small modifications. Like for
Mm-hmm.
example, let's say I like this one. Okay, so I
Mm-hmm.
can do this send to image, and this is why it's nice to have a UI, because when you're doing these kind of things it's not so nice to do in code. Yeah. And then what I can do is maybe I can do I can specify this, like leave the same prompt but just have like small variations to it as well. So let's just try that. Okay, so you can see like it's roughly still the same composition, but you can see like the background color has
Mm-hmm.
changed, the cat has also changed. I can also up the
Okay.
batch size here and get like a few variations on it.
Maybe let's add a blue hat.
Yeah, sure. I think we can try. I'm not sure if it will actually be able to pull this off. because there's another way you can do it if you want like to change like the hat color, but this might work as well.
Yeah.
Yeah. Just if
So it's
you
like a different technique. Like this in painting is actually a
yeah,
different
in
technique.
painting usually is better at these kind of small modifications, but yeah, it happened to be
Oh.
quite an easy prompt for it, so it was able to do it. So you can see that it's still somewhat the same composition, and then now there's a blue hat. Unfortunately, like yeah,
Mm-hmm.
because I'm doing image to image, I can't like specify the like specific area I wanted to change. So you can see that the cat has
Mm-hmm.
also like somewhat changed. Like the cat is still almost the same in terms of color, but like the face is like very different. Like this cat is like super grumpy. This cat is like somewhat excited.
Okay. So basically what happens is that you take the image that you specified, it goes through the VAE encoder this time, right?
Mm-hmm, mm-hmm.
Gets encoded into the latent space, and then instead of starting from a noisy image, we start from that base image, and then we continue generating or diffusing, let's
Yeah,
say.
yeah, we add some noise to it and then continue generating. Yeah, so the
Okay.
noise is this denoising strength. So if I put the denoising strength very low, it will basically
Mm-hmm.
generate an image that is almost the same.
All right.
So yeah,
Interesting.
so you see like there's only like very small variations. Maybe you might notice. Yeah, like there's just like small lighting variations now. But if you go for very high denoising strength, then it will be very different. Yeah. But I think still
Okay.
somewhat the same composition. Yeah. So that denoising strength, yeah, you can see that. Yeah, it completely changed the composition this time. Yeah.
Mm-hmm.
So this denoising strength is like how much noise you add at each step. So like in the middle, and you will get the same composition with slight variation.
Okay.
Yeah.
Interesting. Okay. Should we continue?
Yeah, sure. Okay, so yeah, you can also do in painting. So here I can send to in paint. So in paint is basically it's like image to image, but you can specify like a masked area that you want to change.
Mm-hmm.
So say I just like mask out his hat. So it's black. So it's a bit hard to see like where I've painted. But yeah, maybe we can do it.
Okay.
Okay. His hat's quite big as well. You got a big hat this time. Then you can just leave some white and might be fine. Though it might bleed the color. Okay, let's just color it all out. Okay, so
Yeah.
basically you specify like an area. Okay,
Mm-hmm.
let's see my backside is still full. Okay.
But you didn't say
Yeah, I
blue
didn't
in
say
the
blue.
prompt.
Yeah. But you can see that, yeah. So you can see the cat stays the same, but then it changes that area. And then like
Yeah.
if I
Yeah.
do blue, then it will try to fill a blue hat into only that area. So now you can see the cat never changes because the only part that is inside the generation will be the part that was
Mm-hmm.
painted. Yeah.
Okay. Interesting. But of course, if you I don't know, you've covered part of the cat, for example, its ears, and then the model will generate a new ear, right?
Yes.
So it's not like the model knows that you want to change exactly the hat. It only knows about the area.
Mm. Yep.
Okay. And can you tell us what happens when you do inpainting inside the model? Where is the mask applied exactly?
So for this, there are some models that are trained specifically for inpainting and some that are not. So some that are, if they're trained specifically for inpainting, they will have a channel that takes the mask. But what people have
Mm-hmm.
found is that sometimes the mask is actually not that useful. And what you can do is
Mm-hmm.
even if the model is not trained for inpainting, you can just have it try to like you just do the noise and have it generate the whole image, but then you only replace the pixels in that area.
Oh,
Yeah.
okay. So it's like a hack.
Yeah, yeah, it's like a hack around, so you don't need to train specifically for the inpainting case. And like usually it works
Mm-hmm.
okay, so people just use that. Yeah.
Okay. And what are the models that are trained for inpainting? So this Stable Diffusion 1.5 is trained for inpainting?
I think there will be specific inpainting models. So yeah, you can probably do like Stable Diffusion V15 inpainting. Not sure if there's one on Hugging Face. Oh
Wow.
yeah, there is. Okay. So yeah, there's this
Okay, I
specific
see.
Stable Diffusion in painting. This one is specifically trained for in painting. Yeah.
Okay, interesting.
And as you can see, like in painting would be very annoying to do in code. Like you would definitely want a UI for that, because like specifying like where you want to mask, yeah, not very nice to do.
Yeah, I see why this project gets too much stars.
Yeah, yeah.
I'm not jealous.
Yeah. So you can also specify like other models as well. So like this Reliberate one is actually slightly better, I found. So these are like fine
Mhm.
tunes of the Stable Diffusion model.
Mhm.
Okay, let's see. Okay, yeah, you get more cats. They're slightly sharper, so yeah.
Mhm.
Okay. And so where you find these fine tunes on the community is you go to this website called Civet AI.
Mhm.
Okay. And so yeah, you can find the people experimenting with images. You can also go to this model section and like yeah, so people
Mhm.
publish their models here that they fine tuned.
Okay. So basically, fine tuning means that you take, let's say, a generally trained model. Actually, it's a concept that applies for any kind of model, language models or image generation models. And then you fine tune it for a specific domain. So, for example, the domain can be League of Legends characters or anime characters and so on. And then, like you train a model on this domain specific data, and then when you do inference, it will generate new images that match the data set or the domain that you specify, right?
Yep. Yeah. So you
Okay.
can check out these models. So basically what you do is if you're interested in a model, you click in and then there'll be
Mm-hmm.
here download, but this download will download to your local. So if you're running the auto UI from your local, then you just click this. Yeah, but for me, I'm running it remotely. So what I do is I will copy this link address and then go into terminal and then cd into the correct folder. So when you run
Mm-hmm.
the web UI, so let me roughly show it. Yeah. So you'll run this web UI.sh. Yeah. And
Mm-hmm.
then what it will do is it will pull that repo that I showed you just now. Oh. And then oh, this repo will have a few folders, but when you want to change like what models are available, there's this folder models that Stable Diffusion. There's also a lot of other things you can change. So if I ls models, so you can see you can specify different blip models, control nets. These are upsamplers, so if you want to increase the aspect ratio. And then there's
Mm-hmm.
hyper networks, there's LoRa's, whatever. Okay, but if you're just like you want a checkpoint, then you'd want to go to this Stable Diffusion one. So CD
Okay.
models, Stable Diffusion. Okay, and then what I'll do is I'll basically just like we get the model.
Well
Yeah, so
done.
this
Mm-hmm.
just downloads it from the internet. Yeah, it names it a bit weirdly, so then I have to rename it afterwards. Yeah, but basically once you've renamed it, then you can go to the UI. So where was I? Yeah, and then select it over here.
Okay.
Yeah.
Interesting.
Yep.
Okay. I guess next step is learning about how we can create our own fine tune, right?
Yeah, sure. Okay, so if you want to create your own fine tune, basically what you do is just follow any tutorial that's on like the diffuser's website. So like diffuser's docs. Okay.
Okay.
It's always changing, so for the most part you kind of do want to be looking at the documentation. Yeah, because they're always changing slightly how the API works. Because diffusers I think is quite a new library. I think it's only been out for like a year plus. Yeah.
Yeah.
Yeah, because all this Gen AI stuff is quite new, right? Although Transformers has been around for like 5 years, I think. Yeah. Okay. But anyways, yeah. So you
I
can do
know.
like text to. So there's yeah. You go to this training section, and then there's like text to
Mm-hmm.
image. There's like textual inversion. There's Dream Booth, LoRa. So you can pick whatever you want to go for. Yeah. So I think I'll
Okay.
roughly explain what they all do. So
Yeah.
what Dream Booth does is it trains like the whole model. So where am I? Okay, let's get this ledger back. Okay, so what you do is you would freeze all the other components. So you freeze the VAE, freeze the tokenizer and all the text parts. And then you would just train the unit with your particular images. So what you do is you would have a set of image and captions. You actually sometimes don't need to provide captions because you can use like templates, and then it will just like you just need to specify like the name of your object. For example, if you're training on your dog, then your dog's like called Mike, then you can get like a template generator to like a photo of Mike, a picture of Mike, or a something of Mike, and then like use that as your captions, and then you don't
Oh,
need
I
to
see.
caption your images. Yeah. Then what you do is you pass this into the pipeline, and then you train the unit. So the way that you train it is that you have your ground truth image, you put it through the encoder to get like a latent, and then you use the scheduler to generate a noise, and then you mix your latent with this noise with basically this linear mixture of them, and then you pass
Okay.
this to the unit, and your task for the unit is that it needs to predict the ground truth noise that the scheduler added to this original encoded image, and then you basically just do
Okay.
the MSE loss over here.
Okay. Okay. Okay.
Okay.
Interesting.
Then for LoRa, it's the same thing, but then have you covered LoRa's yet for like your LLM part?
Yeah.
Okay, so basically it's the same thing,
In
right? It's that
the
the unit actually has transformer layers inside, and you can train like all the like QKV, but then if you want to be on lower parameters, then you can basically use the LoRa method and train like lower ranked adapters over it. Yeah, and the nice thing about adapters is you can also mix the adapters, and also you can do like linear interpolations of the adapters. So same thing applies for the diffusion world. Okay.
Okay, actually, I didn't know about this feature with LoRa's where you can mix them and do linear interpolation between LoRa weights.
Oh, I wasn't gonna explain it, but I guess I
In,
can explain it a little bit. Basically the
Mhm.
way that LoRa's work, right? So let's go like LoRa. See if I can get an image. Like images.
So LoRa actually started as a paper for large language models.
Mm-hmm.
It turns out that people applied it for image generation as well.
Yeah, yeah. I mean, it wasn't really about language models. LoRa was just about attention. It was that you could train attention this way. People have also applied
Yeah.
it to convolution actually. So this one is called Lycoris. This one I've only seen in, I mean, obviously I've only seen it in the image world. Yeah, but there's someone who like applies LoRa to everything. Yeah. He's called
Okay.
Lycoris. And obviously he needs this level of power because he's generating anime images. Yeah. It's crazy guy. Okay. But anyways, you
Yeah.
can see that the way that LoRa works is that your original pre-trained weights, you keep them the same, and then you train these lower ranked AB matrices, right? And then what you
Mhm.
do is you plus them together to get your hidden state.
Okay.
Yeah. So when you plus them together, you can always specify constants in front of them, right? So that would make it that you can mix them. And would also
But
make
do
it
you
that you can specify multiple of them and mix multiple of them.
okay? So you add the more AB matrices to the mixture, right?
Yes, yes.
Like,
And then you
but the,
just
the model
yeah, go on.
but the model is not trained to um, use multiple LoRa adapters at the same time. That's the thing.
Yes, but it doesn't know. The thing is, you can just use scalars to trick it. Like when you do LoRa, you actually have to do some amount of scaling as well. Yeah. But what you can
Hmm.
do is like since you know like the magnitude of your H, like under these two LoRas is 1, then what you can do is if you have a second LoRa, you just multiply this LoRa by 0.5 and your second LoRa by 0.5 so that your magnitudes are still the
Okay.
same when you pass into the next one. because
All
this
right, and then
operation
it
is just a plus,
works
right?
as a book.
So your shape at this
Mm-hmm.
h would still be correct, basically, because you're not doing a concatenation. You're doing a reduction already when you do plus. Yeah.
Yeah.
Mm-hmm.
Yes, but I'm wondering how does the model learns to train LoRa adapters in such a way when you add two LoRa adapters, you don't destroy the quality of the generation.
Yeah, yeah. So it kind of
Yeah, I
depends.
guess
Like
I guess it's a research
sometimes you do
question.
destroy it, so your results may vary. Yeah, it's the same thing for like training tokens, right? You can like add one word and completely destroy it as well. So yeah,
Mhm.
results may vary.
All right, let's continue.
Yes. And then what you can also do, which is what I'll be showing today, which is because it's the easiest one to do and the fastest one you can train.
Mhm.
Yeah, which is to just train the tokenizer and train like a new token. So this is usually if you have like a specific subject that you want to train on. Like you have like a specific character that you want, and
Mhm.
you can specify all the features of the character in your caption, but then an easier way to do it, or like a way to get it to be reproduced more faithfully, is to have a bunch of images of that character. You train a new token, and then you pass that token when you want to generate. Yeah.
Okay.
Okay. So yeah, I have that set up somewhere. I think over here. Okay. So yeah, basically whenever you want to use like the diffusers documentation, all of their training code is like, so if you clone the diffusers library, there will be this directory called
Mhm.
examples, and then this example
Mhm.
contains like all of their code. Yeah.
Okay.
So the one we are looking for is this textual inversion. If you can't find it in the docs, it's in the README as well. You want to find out like the command to run it, just like search for accelerate launch. Yeah, then you always find like
Mhm.
this command. Okay,
Okay.
so I've copied that over here. Okay, so this model name, this is like the base model that you will start with. And then
Mhm.
this data directory will point to a directory containing images of what you want to train. So
Maybe
over
we
here
can
I
take a
have
look.
what?
Yeah, let's take a look at the
Okay.
images.
So you actually don't need a lot of images a lot of time. Obviously, the more images you have, the better your output will be. But sometimes you can actually get away
Mhm.
with very less images, especially if the embedding you're trying to train is very close to what the model already knows about. Yeah. So like for example, like
Mhm.
humans. So if you're training like human characters, then you actually usually don't need too many images to get a faithful reproduction. So here I'm training a Windrunner from Dota. She's also in World of
Okay.
Warcraft, but copyrighted. Uh, yeah, so I just have like these three images of
Mhm.
Windrunner. Okay,
Mhm.
so this basic idea that she has like orange hair, she has these green robes things. Okay, and that she's an archer. I think all of them have bows.
Oh,
Right.
wait. Where does the text prompt come from?
Yes. So you can provide text prompt if you want, but when you train textual inversion, a lot of time like just like the first time, you kind of don't, because text prompts aren't very scalable, right? So what you would do
Mhm.
is you would just use like very standard prompts, and then
Uh-huh.
it would just put you would use very standard templates, and then you just replace the template as your caption. Yeah.
Okay.
So you will see that when you run the textual inversion script, there is this parameter called learnable property. So your
Mhm.
property is either object or style. And what this does is affects the caption. Because if you have a style, then you would want like a painting in the style of your style,
Van
a
Gogh.
rendering in the style of your style. If you're training an
Mhm.
object, then you want like a photo of a your object, a rendering of a
Okay.
your object. Yeah.
So basically, this means when you specify after training, when you specify a prompt that contains the object name,
Mm-hmm.
the generated object will look like the data that you have trained on.
Yes, yes, basically, yeah. So this
Okay.
learnable parameter is passed in over here, and then yeah, it's used over here to select like the templating. Yeah, but basically all the
Mhm.
captions over here. You can add your own captions if you want. Yeah, but for the most
Mhm.
part, these are kind of enough. Yeah.
Okay.
They're basically just like synonyms of the same thing. I'm surprised they didn't use picture though. They just use photo for everything. There's like rendering as well. Yeah. Oh well.
Yeah.
Okay.
And this is kind of important for data diversity, I guess.
Yeah. Because you want it to know that the similar thing in all these images is your character, like, and not the
Yeah.
words around it. Yeah. Okay. So then, yeah. So once you have that, you basically just run your script. You can
So
also
how many training steps? Like, is it like we have one training step per image, or how does it work?
you can specify. So like I think the original one is actually quite a lot. So if you go to the readme of textual inversions, so here they went for like 3,000 training steps and train batch size of 1, but then gradient accumulation of 4. So this basically means that each batch the gradient is calculated on 4 images. But here, since I
Mm-hmm.
only have 3 images, the 4 doesn't really make sense. So I just specified a gradient accumulation of 2, because you still want a power of 2 so that it fits nicely in GPUs. Yeah.
Mm-hmm.
And also I toned
But
down the max train steps a lot, so now it's like only 200. Yeah.
but where do the additional training steps come from? Do we do some data augmentation, or we just feed the same image multiple times with different captions?
We basically feed the image multiple times with different captions. I think there's also a flip inside as well. So like there's a 90 there's a horizontal flip. Yeah. There might be.
Okay.
Is there a flip? Yeah, there's a flip here.
Oh,
Yeah.
okay.
So you can see that
Interesting.
when you get item, oh, flip. Yeah, there's a random horizontal flip as well. Yeah.
Oh,
If your
okay.
image is a pattern, then I guess you can add a vertical flip. Yeah. But most people's
Mhm.
images like are only suitable for horizontal flips. I think that by default they only have
Mhm.
horizontal flip. So there is only the variation there. Yeah.
Okay, so what is the ETA now?
Okay, so
It
this
looks
is
like quite fast, right?
what?
It looks quite fast. We're almost halfway through.
Yeah, because I specified very low amount of steps. So like you see like here, like the diffusers people recommend like 3,000 steps. Yeah. For me, I've just gone for like 200 steps. Yeah. So you won't get like a very
Mhm.
good image, but it also kind of depends on your subject. So if the subject that you want to train, like I said, is like human, you actually usually don't need that many steps. But if your subject you want to train is like a monster or something, then you would want a lot more steps. Yeah.
Yeah, because if it's like so let's say Stable Diffusion was trained on the Lion dataset, right?
Mm-hmm.
So this is the initial distribution of the language model, of the image generation model.
Mm-hmm.
And then you come up with a completely different object that is completely out of domain, right?
Mm-hmm.
There is no zero-shot capabilities when you do inferencing, and there is no transfer learning capabilities. So you need to train the model on much more training samples.
Yeah. Okay.
Um,
So
okay, what is this validation steps? What are we validating exactly?
so this validation steps is just so that because I'm logging it to weights and biases, so we can see. Okay, I can open that. So that's basically
Okay.
like how many steps it will run for before it logs to weights and biases. Okay.
Okay. By the
So
way, we are super super fans of weights and biases, right?
yes, yeah.
Oh, actually, I didn't know weights and biases allows you to log images as you train.
Oh, yeah, it
Yeah,
does. It's really nice. So you
really
can
well
see that
done,
actually
weights
for
and
this one,
biases.
at the start it was already actually not too bad, but you can see like over time it gets better. So at the start it doesn't really get the green clothing that she has, but you can see like
hmm
towards the end she's always wearing green clothing. Yeah. What
But
the
I'm
heck?
wondering why why is the style a bit different?
Oh, because I specified chibi. So are you
Okay.
familiar with what chibi is?
I don't know this TV.
Okay. So okay, that's quick anime. Yeah,
Yeah.
chibi is like small anime characters. So
Okay,
like small
okay.
cute anime
And
characters. So you have the full size, and then like chibi is like small. Yeah.
okay, so this is like a a style that you enforce, or
Yeah. But
like
as you can see, Stable Diffusion 1.5 by itself is actually not very good at the chibi style. Yeah. So
yeah.
yeah.
So it's not just us who are not so much familiar with the chibi culture.
Yes.
Stable diffusion as
Unfortunately,
well,
yeah.
right?
That's why all the anime people are like trying to fine tune it. Yeah. Okay. So yeah, so once you're done with training, there's this output directory that you can specify, like over here.
Mm-hmm.
And then when you
Mm-hmm.
check your output directory, you'll get this learned embeds.save tensor. Yeah.
Okay.
Then what you
Because
have.
we've only trained
Mhm.
because we've only trained the token embeddings.
Yeah. Okay, then what you have to do is you have to move uh, this save tensor into your auto UI download. Can I get there? Oh no, I didn't specify enough. Okay. Then do. Okay. So I happen to know where I installed auto, obviously. Okay. And then you pass it into
Mm-hmm.
this embeddings folder. Okay. And you
Mm-hmm.
also give it a name so that you know what it's about. Okay, so let's just call it TI Wind Ranger. Okay. Dot
Which stands
save
for
tensors. Oh, because like the character that I was going for was this character, right?
okay,
Yeah.
more anime culture.
This is Dota.
Okay.
Okay. Okay. So now if I go back to the UI, so there's this button over here. Don't know what the button is called actually. It's just a button. You click it, then it tells you all the embeddings that you have, and so you can see now it
Mhm.
knows about this TI. Oh, because I tried it out already. So there's a TI Windrunner and a TI Windranger. Yeah. I
Mhm.
named this one Runner, right? Okay, so let's go for Runner. Okay.
I think Ranger.
Ranger? No, I think I went
Yeah,
for Runner.
you go back to the
Okay,
tool.
it's Ranger, you're correct. Okay. Paying attention. Okay. I'm not somehow. Okay. So then you can see it will just like put it inside the prompt over here.
Mhm.
Okay, so I can close it.
So
Yeah.
this would basically take the embedding and blend it with a original pre-trained image generation model.
Yep.
Okay,
Okay. Then yeah, you get a bunch
let's,
of
let's.
Wind Ranger. Yeah.
Oh,
But
but where is the text prompt?
oh, the text prompt is over here because I just specify like directly
Oh,
the embedding. Yeah.
okay, okay.
And I also know like a better prompt for it, so I can let's try this.
Hmm.
Yeah. So this saves like a template style. So I applied my template, so you can
Hmm.
see the prompt is now a lot longer. So there's 8K portrait of like TI Wind Ranger, blah blah blah. Okay, and
Okay,
then I also know this uses the Dream Shaper one. Okay, so this one the
okay.
quality should be a lot better. Okay. So yeah, if you train an embedding for like 1.5, you can actually use any model as long as like any fine-tuned model, as long as the base is also 1.5. Yeah.
Okay,
So yeah, you can see I can
nice.
generate a bunch of wind ranges as well.
Okay,
Yep.
and can we see if the fine-tuned model forgot about what it learned before? Like, I don't know. Is it still able to generate our hello world picture?
In this case, yes. So I told you about like three different ways to fine tune, right? There's Dream Boost. Okay,
Mhm.
let's go back to that. This. Oh, my slides were here. Okay, so there was like Dream Boost and then textual inversion and then LoRa's. So if you do Dream Boost, since Dream Boost modifies the unit and changes like the original pre-trained weights, that one will cause
Mhm.
catastrophic forgetting. Yeah. But
Okay.
if you go for LoRa's or textual inversion, you actually won't have forgetting because the original model is still there. In the case of textual inversion, you've just invented a new word. So if you've invented a new word, if you just don't specify that word, then it just has like the original behavior,
Yeah,
right? Yeah.
exactly. Yeah.
Yeah. Then if you
All
use
right.
LoRa's,
Then
if you don't have the adapter, then you just get the original implementation. Yeah.
oh, but if you have the adapter in LoRa, kind
Yeah.
of you kind of have some catastrophic forgetting as well.
No, because you can just specify 0 here, right?
Oh, ah, yeah.
Yeah.
Yeah. But I mean, if you really apply the
Yeah.
adapter.
You apply the LoRa, then yeah, all bets are off.
Okay.
But the idea is that if you're applying the LoRa, then you wanted that style or character, right? So yeah, it's not that it forgot, but that you said something.
Yeah. Yeah. Okay.
Yep. Okay.
Anything
So
else to discuss?
yeah, which is that if you're playing around with Civet AI, when you download the
Mm-hmm.
models, usually they have like a specific way of prompting them. So what you want to do is copy their way of prompting. And so, yeah, so you can see their prompts, so you can copy their prompt. What you can do is also copy all of their parameters by just pressing this copy
Mm-hmm.
generation data. Then
Mm-hmm.
inside the UI, you paste this into
Mm-hmm.
here, and then use this arrow button, and then it will bleed into the rest of the configs. Yeah.
Okay.
And then now I should be able to, no, don't think it worked actually. Yeah, somehow for this case it didn't work. Okay, let's go for a different example. Okay, so let's go for one of the Dream Shaper ones. So actually I stole that prompt from the Dream Shaper examples. So I think I was using 7. Yeah, it was this one.
Mm-hmm.
Yeah. So you can just copy generation data. Okay, here let's reset, delete prompts. Okay, let's do this. Boom. Okay, so you see that there was seed and everything, and let's not go
Mm-hmm.
over upscalers because it will be quite slow. So let's take out the high res fix. Okay. So now when we generate, oh no, it's still quite slow. It's because the image
Yeah.
is quite big. Yeah, because it goes like 512.896. Yeah, but I think we can. Yeah, but basically what it will do is it will generate. Yeah, so you can see that this first image is what followed this seed, and so this first
Mm-hmm.
image looks like this image over here.
Mm-hmm. Okay.
So yeah, so now, yeah, last thing I wanted to talk about was like community and where you can learn more. So Stable Diffusion, a lot of artists are interested, so you can just go on YouTube. Yeah. So
Mm-hmm.
you can just go on YouTube, search like Stable Diffusion. I'm sure you'll find like a bunch of stuff. Yeah.
Yeah.
So yeah, so you can watch like these Stable Diffusion beginner guide, or like yeah, whatever else you have. Okay. Why is there tech lead? Okay. In terms of community, there's a Stable Diffusion subreddit. So, subreddit. Okay. Usually people don't
Mm-hmm.
really talk about like fine tuning or like stuff, because usually here is just artists. So usually here is you would only go onto the subreddit or subscribe to the subreddit to like see ideas of what people are generating. Yeah, though some of their ideas
Mm-hmm.
are bad. Okay. And there's also a Discord. I think this is on. It's just Stability AI Discord. Okay.
Ah, yeah. So this means you get updates about like the stable diffusion models coming from stability AI.
Yep. I can show you roughly what's inside the Discord. 'Cause I'm in.
Yeah. Oh, basically, also they have like a text to video, I guess, or image to video models.
Yeah, not image. Yeah, they have image to video. Those ones are like GIFs. So you start with like a static image and then you like animate GIF. And there's also
Mm-hmm.
text to video stuff. Yeah.
Yeah. Pretty interesting, I guess.
Yeah, but needs a lot more
Where
resource.
are they, Jack? I wanted to see them
Huh?
in your tutorial. I wanted to
Oh,
see them in your tutorial.
no, that will be next tutorial. This tutorial will last forever if I go over everything. But yeah,
Yeah.
you can just look it up, right? So if you go onto Hugging Face, I'm sure you can find them. So like let's see models. I'm sure there's like a text to video. Oh, there's image to video. See, so that you can like text the video, So yeah, just sort by trending or like sort by most downloads. Usually that's the one that works. Yeah. Then this zeros. I've tried this one. This one's a bit like not that nice actually. But it's the most downloads, yeah. You see they have this example like Darth Vader surfing waves, yeah. Okay.
Nice.
Yeah, there's also the image to video stuff. So Stable Diffusion has some image to video stuff, so which I guess is the most downloads, and then there's other stuff. It's like drastic difference. It's like thousands, and then there's like less than 1,000. Okay.
Yeah.
Yeah, but that
We
this
go
code
back to
also
the
has a
Discord.
plot, so you can also like see it generate stuff and then like vote for stuff. Yeah, I think they use this to select their models and like do their evaluation. Yeah.
Okay.
Yep. Those things. There's also an anime channel, of course. Yeah. People generate anime images. Yeah.
Nice.
Disproportionate amount of females, but I guess it tells you who's on the Discord. Yeah. And yeah, that's all I wanted to talk about.
Yeah. Nice. I guess we learned a lot about image generation models, how to use them, how to fine tune them. Also learned a lot about anime and imported culture.
Yes.
Yeah, thanks, Jack, for having this tutorial. And thanks, everyone, for watching. Make sure to follow us on LinkedIn and Twitter. Follow Jack as well. By the way, he's creating a startup about testing language models. So if you need to test your language models, make sure to use his product, right?
Golden Sand. Yeah.
Yeah. All right. Thanks all, and see you next time. Bye bye, Jack.